Hello everyone, welcome back to CodeMaster. In today's video, we will learn about recursion. Whether you are preparing for coding interviews or learning data structures, recursion is a must-know topic. So let's break it down step by step. I will explain how recursion works, where it's useful, and even walk you through some Python code examples. Let's get started. So what exactly is recursion? Recursion is a technique where a function calls itself to solve smaller instances of a problem. It's like solving a big problem by breaking it down into a smaller, similar subproblems. The function keeps calling itself until it reaches a base case, a condition where the recursion stops. For example, calculating the factorial of a number is a classic recursive problem. Factorial of n equal to n into factorial of n minus 1. We solve the larger problem by solving smaller versions of the same problem. It's like looking into a mirror that reflects another mirror. The pattern repeats itself. Let's now understand how recursion actually works. A recursive function has two main parts. First one is base case and the second one is recursive case. In the base case, this stops the recursion and prevents infinite loops. In the second case, recursive case, this breaks the problem into smaller chunks and makes a recursive code. Imagine recursion like a series of doors. Each recursive call opens a new door and you can close the doors until you reach the end of the hallway. The base case. Once you hit the base case, you close the doors one by one, returning the results back through each function call. So the steps in recursion are: we will call the function with an initial input, we will divide the problem into smaller subproblems, solve the subproblems recursively, combine the results if needed. Let's walk through an example to see recursion in action. We will calculate the factorial of 3. So in the first step, factorial of 3 equal to 3 into factorial of 2. So factorial of 2 we need to calculate. It will be 2 into factorial of 1. So factorial of 1 equal to 1, which is the base case in finding the factorial. So now we return the results back, which is 3 into 2 into 1, which is equal to 6. This back and forth flow happens through the call stack, where each function call waits for the next one to finish and then returns the result. Here's a general structure of a recursive function in Python. So first we will define the recursive function. We will pass the parameters. If base condition, we will return the base case value, else result equal to recursive function of smaller problem. We are making it into smaller chunks. We will return the process result of result. Let's implement factorial in Python. This is the factorial calculation implementation in Python. So we will define the factorial of n. If the n equal to 1, we will return 1, which is the base case, and 1 is the base case value. In the else case, we will return n into factorial of n minus 1. If you call factorial of 5, the function will recursively calculate 5 into 4 into 3 into 2 into 1, which results in the 120. Now, let's talk about the efficiency of recursion. Time complexity is order of n for linear recursion like factorial or Fibonacci, order of 2 raised to n for exponential recursion like naive Fibonacci. Space complexity is order of n due to the recursive call stack. Can be reduced with optimization like tail recursion or memoization. Recursion comes in many forms. Let's break them down. Direct recursion. Function calls itself directly. Indirect recursion. A function calls another function which in turn calls the original function. Tail recursion. The recursive call is the last operation in the function. Head recursion. The recursive calls happen before other operations. Tree recursion. A function makes multiple recursive calls. For example, Fibonacci. Each type has its pros and cons, but understanding them helps you decide the best approach for different problems. So recursion is super useful in a variety of real-world problems. Mathematical computations like finding the factorials, Fibonacci series, GCD, and etc. In trees and graphs algorithms like traversals and depth first search. In divide and conquer algorithms such as merge sort and quicksort. Dynamic programming, solving subproblems recursively. For string manipulation to find the palindrome checks for string reversals. Whenever a problem has a smaller, repeatable substructure, recursion is usually a great choice. Let's quickly go over with the advantages of recursion. Simpler code. Recursive solutions are often shorter and more intuitive. Solves complex problems easily. Ideal for problems with repetitive substructures like trees. Natural fit for divide and conquer. Recursion aligns perfectly with algorithms that split problems into smaller pieces. But recursion isn't perfect. It has some disadvantages also. So memory overhead, performance issue, difficulty to debug are some of the disadvantages recursion have. So memory overhead means recursive calls consume stack space, which may lead to stack overflow. Performance issues, recursion can be slower and less efficient than iteration for certain problems. Difficulty to debug, tracking recursive calls and understanding stack frames can be tricky. Recursion isn't just theoretical, it's used in real world applications like web crawling, visiting links on a web page recursively, file system for navigating through folders and subfolders, data parsing, parsing nested structures like JSON or XML, AI and games, solving mazes, game state trees, and puzzles like Sudoku. So, in this session, we explored the concept of recursion and how it works, the recursive algorithm with Python examples and Python implementation, time complexity and space complexity, then where recursion shines, like its advantages, limitations, and real world use cases. Mastering recursion is key to solving many complex coding problems, and with practice, it becomes a natural way to think about problem solving. So that's wrap on recursion. In the next video, we will discuss about some of the classic recursive problems. So if you found this explanation helpful, don't forget to like, share, and subscribe to CodeMaster for more coding tutorials. Stay tuned and happy coding.